Day 14 of 75, and your string solution is correct, but it's timing out. Here's the thing nobody tells you. In C++, the container you reach for is your performance. Pick std, map by reflex, and you eat a log factor and pointer chasing on every lookup. Today we turn O, in superscript 2, brute force into cache-friendly, hash-accelerated code. Anagram grouping, sliding windows, and Rabencarp from scratch, with the overflow trap that breaks half the implementations online. Let's make your solutions fast enough to actually pass. Start with the classic, group anagrams. The textbook move is unordered _ map string, vector string, where the key is the words sorted alphabetically. Eat and T both sort to E, so they land in the same bucket. It works, but look closer. Sorting each word is O, K log K, and you pay that for every single word in the input. On long strings or huge dictionaries, that hidden log factor is exactly what pushes you over the time limit. The key construction is your bottleneck, not the map. So kill the sort. Instead of a sorted key, build a frequency signature. Walk the word once. Count each letter into int counts, 26, then turn that into a key, a string of 26 counts, or a packed integer. That's OK. Per word, no comparisons, no sorting. Same grouping, same correctness, but key construction drops from K log K to linear. On a real dictionary, that's roughly a 3x speedup before you've touched anything else. The lesson, the cheapest key wins, and sorting is rarely the cheapest. Now the container itself. Unordered _ map gives you average O, 1, lookup, but every entry is a heap allocation and a pointer hop that wrecks cache locality. When your keys are just lowercase letters, you don't need a hash map at all. Int frequency, 26, sits in a single cache line, 0 allocation, direct indexing by C-. 4-character frequency problems, swapping mapchar. Int for frequency, 26, can take you from 180 milliseconds to 12. One change, same logic. That's a TLE turning into a pass. Same idea scales to the sliding window. Longest substring without repeating characters. The brute force checks every pair. O, in superscript 2. The clean fix is an unordered _set. Expand the window, erase on collision, O, in, but with allocation churn on every insert, and erase. The fastest version drops the set entirely. Int last _scene, 128, indexed by the raw character. You store the last index you saw each character, move your left pointer in constant time, and never allocate once. On a 1 megabyte string, the array version isn't a little faster. It's a different league on cache misses. Now substrings, where hashing really earns its keep, Rabencarp. You slide a window over the haystack and compare a rolling hash instead of the full substring. Polynomial hash. Treat the string as digits in base P, like 31, modulo a large prime. Roll forward by subtracting the leaving character, multiplying by P, adding the new one. The trap. In C++, this overflows. Multiply two 32-bit values, and you hit undefined behavior fast. Do everything in unsigned 64-bit. Keep your modulus well under 2 to the 32, and reduce after every operation. That's how you stay correct. One hash isn't enough. Collisions mean false positives, and on adversarial contest input, a single weak hash gets hammered on purpose. So double hash. Compute two independent rolling hashes with different bases and primes, and only treat it as a match when both agree. The chance of both colliding by accident is astronomically small. When the hashes match, then, and only then, verify with a real character comparison. Hash to filter, compare to confirm. That combination is what makes Rabencarp both fast and actually safe. Benchmark it against std. String. Find on a 500 kilobytes haystack, and you'll see when custom hashing pays, and when the built-in already wins. That's the real skill. Knowing frequent, 26, beats any map for lowercase, a frequency signature beats a sorted key, and a verified double hash beats naive matching. Day 14 done. The takeaway. In C++, choosing the container and the hash is the algorithm. That's the line between an interview pass and a TLE. Subscribe for day 15.